So here, take ascending loop of moonlight. Sodium, potassium, 2 chloride. Take sodium, potassium, 2 chloride in the cell, and here we have sodium, potassium exchanger, which takes sodium in the blood, potassium in the cell. Potassium is brought in the cell and it diffuses out from both sides and create an electrical chemical gradient which pulls magnesium and calcium inside. So basically, in thick ascending limb, we are taking ions inside with sodium, potassium chloride, and paracellularly reabsorbing magnesium and calcium through positive lumen. The mechanism of calcium reabsorption is positive lumen generated by back leak of potassium. Okay, it's 10%. In distal convoluted tubule, the most important channel is sodium chloride, and sodium chloride channel with that thiazide act. Okay, we just have to remember it takes sodium and chloride from the urine and in the cell. In the cell, there's again sodium potassium channel ATPase where sodium goes in, potassium comes back. So not of significance. It just create gradient which pushes this inside. At the same time, we have to check that there is a channel. Here we have specific channels of magnesium and calcium which takes sodium, magnesium, and calcium from the urine in the tubular cell. In distal convolute tubule, we have special channels of magnesium and calcium, which takes calcium, magnesium from the cell, urine to the cell. On the other side, on the blood side, we have calcium sodium exchanger. So we are taking sodium in the blood, which is going back in the cell in exchange of calcium. Calcium was coming through a cell, through a channel, and then we are reabsorbing calcium in the blood via sodium calcium exchange, which is to be more important because this is the channel which increases calcium in the blood and because of that thiazide have no effect on this calcium because there is specific channel. Chloride is diffused back in the blood. Nothing to note. Impermeable to water is something I have to remember. PTH act here and it increases the sodium calcium exchange. PTH act here increases this channel, sodium calcium channel, which takes more calcium in the blood. Calcium reabsorption is increased PTH act on sodium calcium exchanger, which we give takes sodium out from the blood and brings calcium inside. Okay. The most confusing is collecting tubule with number 3 type of cells. Principal cells, alpha intercalated cells, and beta intercalated cells, and different receptors. Okay, in collecting tubule from the urine to the blood, chloride goes on its own. Then there's a water channel which takes some amount of water. And then there's a urea channel which is having a receptor, UT1 receptor. Then there is a potassium channel and a sodium channel. Sodium reabsorbing channel and potassium excretion channel, which takes sodium potassium out in the urine and brings sodium inside. Here I have same sodium ATPase channel, which takes sodium in the blood, brings potassium in the cell, make a gradient, and we have more potassium in the cell, so potassium goes via this channel. Potassium goes in the urine, but sodium comes back. Okay, these both channels help this channel to run. And we have a water reabsorption. And water reabsorption is based on ADH, ADH-V2 receptor, which increases this aquaporin on this membrane, aquaporin on vesicle membrane, and increase water reabsorption. Easy. Now move next. Alpha intercalated cells. Alpha intercalated cells are having proton ATPase and potassium proton antiput ATPase and bicarb chloride antiput. Aldosterone act here. Okay. The main function of aldosterone is to excrete proton and excrete ketone and increase potassium. Okay, this is something I have to recheck. Aldosterone increase apical potassium conductance. Conductance in apike is increased and it increases this pump sodium proton pump. Sodium proton pump. Aldosterone increases sodium potassium pump. Here is sodium potassium pump. In alpha intercalated cells, so you have to check alpha intercalated cells. In alpha intercalated cells, a aldosterone increases proton pump, which excretes proton. Okay, and increases proton chloride exchanger activity. So in alpha intercalated cell, aldosterone is increasing this proton exchanger. Proton ATPase activity and increasing proton excretion. Aldosterone in alpha intercalated cell is increasing proton excretion and increasing bicarb chloride channel activity because we are losing a lot of proton and bicarb is reabsorbed and exchanged with the chloride. Acid is being lost, bicarb is being reabsorbed. Now I need to check what aldosterone is doing up here. It's acting on sodium potassium ATPase. Increase apical potassium. Okay, this potassium going out is increased by aldosterone potassium excretion. Sodium potassium pump. Sodium potassium pump. Sodium potassium नहीं है. It's where sodium potassium pump. Increase sodium potassium pump and more potassium goes in the cell which is excreted. So aldosterone is increasing potassium excretion in principal cell and in alpha intercalated cell is increasing proton excretion. Aldosterone in principal cell is increasing potassium excretion and in alpha intercalated cell increasing proton excretion. In beta intercalated cell there is a channel called chloride bicarb, which takes bicarb in the urine and brings proton in the cell. Now you have to remember the use of beta integrated cells.